Welcome to Carlton's Math Corner. Today we're going to talk about least common multiple. Before we begin, please make sure you have your math journal as well as your vocabulary packet out. It is very important that you're taking notes as well as writing down definitions of vocabulary and sketches or examples of them. Let's look at something to put a smile on our face before we begin. First of all, can you believe that this owl was not picked for Hogwarts? I mean, I just can't believe it. This owl is so cute, just adorable. Well, to start off, let's make some observations. Well, what do you notice? You are absolutely right. These are multiplication arrays. And what number seems to remain the same every time? Yeah, the width. Do you notice the width is always 6? Okay, and then what is the area of each one? Well, the first one's 6. Absolutely. How about the next one? 12. Yep, and then goes to 18 and 24 and then 30. Sorry, my computer is quite slow. 30, and then the next one's 36. And then what do you think would come next after 36? Yeah, exactly, 42. How did you figure that out? For those of you that said that this 6 remains the factor that is common, and so if you look at these numbers, they're all counting up, and they're all counting up by 1. So the next number would be a 7. So it would be 7 times 6, and 7 times 6 is 42. Nice job. Can you recall what these numbers are? Well, in mathematics, we refer to them as multiples. Multiples are numbers that can be divided by a number. In this case, our example, it was divided by 6 and without a remainder. And so you get an answer as a whole number. And so we're going to be working with multiples today in order to find a least common multiple. Let's look at this example. Okay, so looking at this example, what do you notice? Yeah, do you notice up on top here, each one of these numbers are being multiplied by these factors. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, etc., etc. And then it does that also for 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, and then same thing as 16. 16 times 1 is 16, then 16 times 2 is 32. And notice, I mean, it goes on and on. I mean, yes, this factor only goes to 16, but it could go on infinitely. That means it can go on forever. Multiples are numbers that keep multiplying on. All of these, like this 3 is divisible by 1. 3, because I can go, this 3 right here, 3 divided by 1 is 3. 6 divided by 2 is 3. Like I can get back to the original number that I began with. And so multiples, I could take these original numbers and I can multiply them by 1,000,000 if I wanted to. My point is that it infinitely goes on. And what we are trying to do today is look at these multiples and try to figure out the smallest positive number that is divisible by each number. So we're looking for the common number that they share, the common multiple that they share. And we're looking for the first one that they share. It's not called greatest common multiple because remember, these multiples go on infinitely. So it'd be really hard for us, actually it would take us more than our lifetime to find the greatest common multiple. So we are going to look for the first multiple that they share, and we call that the least common multiple. And we abbreviate that as LCM. And so if you look at these numbers, 3, 12, and 16, if you look at the multiples, notice the first number that they share is 48. And so we refer to that as their least common multiple. And I want you to notice that it's not two of them that share 48, it's all three of them. They all three share the 48. Okay, so here's another visual of that. Do you notice that all three of the rectangles, they have an area of 48. So 3 times 16 gets me to 48, and that's my top number. That is this factor. 12 times 4 is 48, and that is my factor that I began with. And then 16 times 3 is 48, and that too is the factor that I began with. And so each one of them, since they have a common multiple, their rectangular array has a common area as well. Now, this is one way that we can find least common multiple, just by listing out all the multiples. Sometimes, though, we come across numbers where it would take a long time to find a common multiple. And so there is another method that I want to show you, and you can choose which method is best for you, but this is called a factor tree method, and we've used factor trees in the past to find prime factorization. But this time we're going to use it to find least common multiple. So I want you to look at this method. So first of all, here are the trees that I created. So my numbers that I'm using is 60 and 100. Those are the ones that I am trying to find the least common multiple with. And notice that I started off with both of them. I tried to find two factors that I can use just to multiply to get to each number. So 60, I broke it down into two branches, 6 times 10. And then I noticed that 6 and 10 are composite numbers. They're not prime numbers. And so I didn't circle them. And I decided, hey, I know that I can actually draw two more branches off of each of them because I know 2 times 3 is 6. So that's what I did. And then 2 and 3 are prime numbers, so I circled them. And I did the same thing with 10. 2 times 5 is 10. Notice they're prime numbers, and I circled them. Then over here, for 100, I did 10 times 10 is 100. And then I broke them down into two more branches, 2 times 5 and 2 times 5, and those are prime numbers, so I circled them. Now, normally in prime factorization, I would write down, how many 2's do I have, how many 3's, how many 5's, and I'd multiply them together. We're not trying to find prime factorization, though. We are trying to find least common multiple. And so what I do is I wrote down what the prime factorization would look like. Like for 60, I know I have 2 2's, I have 1 3, and I have a 5. And then for 100, I have 2 2's and then 2 5's. Notice I lined up the 5's, there are no other 3's, and then I lined up the 2's. And then I asked myself, well, what do they have in common? Well, first of all, do you notice they both have 2 2's? So since they both have 2 2's together, then I basically wrote those down, 2 and 2, because they do share that. And then do you notice they also share 1 5, not 2 5's, but they share only 1. And so I wrote down the 1 5 that they shared. So 2 2's and 1 5, and then I multiplied them together and I got 20. Then over here, I wrote down the things that were different. Well, did you notice that this one has a 3 and this one doesn't? So that's different. And then this one has an extra 5 and this one doesn't. And I can even visually see that this has an extra 5 than this. And so I wrote that down. Well, 3 times 5 is 15. Now, I'm still not done yet because do you notice I have two answers? I have a 20 and a 15. Well, in order to get one answer, I'm going to multiply them together. 20 times 15 is 300. It equals 300. Well, that is actually my LCM. So my LCM for this problem is 300. Now let's look at a word problem. Ling needs to buy paper plates, napkins, and cups for a party. Plates come in packages of 12, napkins come in packages of 15, and cups come in packages of 5. What is the least number of packages she will have to buy if she wants to have the same number of plates, napkins, and cups? Well, when I read a word problem, I read through it first, and then I reread it because I'm trying to find important information and I'm trying to figure out what concept I am trying to use in mathematics in order to solve it. And so in this case, as I'm rereading, it says plates come in packages of 12. Well, they come in packages of 12, but do we know how many packages Ling bought? No, like it was never given to us. It just says that they come in packages of 12 and napkins come in packages of 15 and then cups in 5, but we don't know how many she bought. And this other keyword, it says, what is the least number of packages? Well, we don't know how many packages again. And so since I don't know how many packages are actually bought, in my mind, I start to think of multiples, because multiples, you don't know when it's going to stop. Like, we can figure out when it stops if we're looking for least common multiple, because then there's an end point. But for anything else, we don't know that. So I know that we're going to use least common multiple in order to solve this. And I am going to actually use the list method first. And so I'm going to take 12, 15, and 5, and I'm going to find the multiples. So I'm going to start multiplying out by 1 times 2 times 3 times 4 times 5. And so when I look at this, here's what I get. And I just am going to keep going until I figure out where there's a number that they share. And so do you notice that the first number the 5 and 15, they share a 30, but that's not, and they also share a 45. But notice the 12 does not share them, and so, or share those numbers. So 60 seems to be the only multiple that they all three share, or not the only multiple, but at least the least common multiple that they share. And so that is going to be our answer for this problem. And so I'm going to label this 60, and we're looking for packages, number of packages, so I'm going to label it with that. Now, I did also do it using the tree method. I just want you to see what I did. Now, when you look at this, now 5 is already a prime number, and I could have just circled it, but I just wanted to show you that it really only has factors of 1 and 5. And then 15, 3, and 5. 12, it breaks down to a 3, a 2, and a 2 as prime numbers. And so I listed the things that they have in common. They only share a 3 and a 5. And notice it is in common with at least 2 numbers. So whenever you have 3 numbers or more, you're looking for what is in common among 2 or more of the numbers. Okay, so notice 2 of the numbers share 3, and this one shares a 3. And so I wrote that down. And then these 2 share a 5. So I wrote that down. And so when I multiplied that together, I got 15. Now I am also going to write down the things that are different. Well, I could write down the 1, but the 1's not going to change anything. So I didn't write that down. But notice there's 2 2's left. So I wrote those down. So 2 times 2 is 4. So 15 times 4, I get 60. Same answer. At this time, I would like for you to try 2 problems on your own, and these are due for class tomorrow. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.